Welcome everybody, we're going to get started. This is our second afternoon session of the OSGi community event. My name is John Ehrig. I'm the Executive Director of the OSGi Alliance. I know several of you out there are already members of the OSGi Alliance, but if you're not a member, I would like you to consider joining. We're doing a lot of great work at the Alliance, and we could always use help. And if you can go to the OSGi website, osgi.org, and check us out and think about becoming a member, we would certainly very much appreciate that. It is with great pleasure that I introduce today Ray Auge, who's going to be talking about, from LifeRay, who's going to be talking about massive enterprise product migration to OSGi as today's topic. Again, welcome and thank you for coming. Ray is a senior software architect at LifeRay, and he drives platform modularity and improvements designed to improve the quality of the developer experience. He is a CS graduate of, what is that?
Laurentian University.
Laurentian University, and is a co-chair of the OSGi Enterprise Expert Group, and he is an OSGi board representative for LifeRay. And please join me in welcoming Ray. Thank you.
Hi everybody, thanks for coming. I'm going to talk about a massive migration, and massive in terms that I understand it, because we started off with a product that was a Java EE product, and it still is a Java EE product, but it had roughly, I'd say, between 5 and 6 million lines of code. So it was almost comparable to the app servers that it needed to run in size and complexity. When you try to take on this kind of undertaking, this kind of migration, you have to answer many questions. What is the strategy? What's the approach that you need to take to deal with all the issues you're going to find? And there are some recommendations out there on how to take this on. You might hear of strategies such as the super bundle strategy, which is you start by taking your entire application, create one monolithic OSGi bundle from that, and then run that inside the framework. And then slowly decouple the application into more modules from there. That's fine. That's one approach. Another approach might be to just start from scratch. Forget the legacy code and just start building a new application with OSGi as the first class concept. Or you could take another approach, which is to keep your application the way it is, create an embedded framework, and bridge between the two, and then eventually migrate towards a more modular solution. And so you need to choose one of those strategies, and there may be more strategies, but those are the ones that I'm familiar with. You need to choose the strategy that's going to be appropriate for you, for your situation. In our case, we needed to continue to deliver a product to customers. So we couldn't do, first of all, we never wanted to do a complete rewrite. That's just suicide, as we all know. Two, we were a web application. In other words, we ran inside of app servers, and we had been for a decade. And we have functionality that depends on that requirement. And in order to continue to deliver a product, we need to stick to that limitation. So the only sane course of action was to create an embedded framework and to go from there and slowly decouple your application. But there's other concerns that you need to think about when you're doing this. And if you're familiar with BJ Hargrave's paper, who's the CTO of the OSGi Alliance, he's written white papers, and he's actually done several presentations on the notion of services first migration, which is the concept of You redesign your application before even going to OSGi to rely on services, so that when you move to OSGi, your application is already decoupled in the way that the interaction between the logic of your application is through services. That may seem a daunting task, but the fortunate thing is that in the vast majority of cases, what you have probably already looks like services. And so once you begin to think of what you look at what you have, you can take this into consideration. So let's get to the meat of what I want to show you. The very first thing, as I said, was to create an embedded framework. The OSGi specifications provide a very nice API for you to create an embedded framework. It's literally trivial code to do this. So that's the first step. Create an embedded framework which runs inside your application. And then we pass a series of properties, and these are the properties that we define our application to be necessary from our application. For us, we had literally tens of thousands of configuration options that we had to map somehow to the modules so that they could see it and whatnot. So in our first iterations, we just literally dumped as much information as we could into the OSGi framework. And then from there, we just started to break the system down. But this was the first step. But we're a web application. And so we can't necessarily live or allow the framework to live on its own life cycle separate from our web application. We need to make the two life cycles sync with each other. And so here we have a simple example of a context initialize method in a servlet context listener, which takes a couple of steps. So first it initializes the framework. So this method here is simply calling back to the initialization code that's written in some other class, just a helper. But what you'll see here is that there's a super context initialized. And this is because, as many your applications may be, it's a Spring application at its core. Tens of thousands of beans defined in literally around 50 different Spring configuration files. And so we still want that to happen. So as a first step, we're kind of syncing the life cycle. So with the web application, but also invoking the Spring application context to be initialized. And then we broke this into two steps so that we could have a pre and post kind of behavior where during the initialization phase, we could do some bootstrapping, then rely on that from the Spring context, and then further continue on if we needed to in a second startup phase, in a second level startup phase. You would see the opposite in the destroyed method. Okay? So, but this isn't necessarily just enough. We could have initialized, or you could think that you might initialize a Spring framework or an OSGi framework directly in your same class loader as the web application you're living in. But if you need to support multiple different app servers, you come to the point where, or you come to the realization that different app servers have a different view or give you a different view of the world, some of which contain OSGi itself or themselves. And so, in order to provide our modules a consistent view of the world across the different deployments that we had, we needed to isolate our OSGi container from the app server's OSGi container, and potentially even other APIs, because there's several other APIs that the app servers arbitrarily provide you which may conflict with what you're trying to do in your application. So this is just a requirement that we had because we had to maintain this ability to run in app servers. But it may, depending on how complex your application is, you may or may not have this requirement. So what we had to do is we had to create an isolated class loader. And this is effectively the list of bundles that are contained in the folder that the class loader is going to read and initialize through configuration. And in there, you'll see it has Eclipse OSGi. It could have been Felix. It could be Dopplerfish. It doesn't really matter. We're using the framework API. So as long as there's one found, we're initializing the OSGi runtime that's there. And we also have some other framework extensions, which is another OSGi specifications to add functionality to the framework during its startup. So we were able to not only create an isolated framework, but then add some functionality that we needed to also be in isolation inside the class loader of the framework. Still not enough, because now you come to the realization that Spring has a life cycle which you may need to interleave with the initialization and destruction of the framework. And this is again because we're trying to merge the two worlds of a very complex Spring application with an OSGi framework. And so we further broke the Spring context into two chunks. And this was basically to give us an ability to interleave at a couple of different phases. So infrastructure pieces that needed to initialize and be made available to the OSGi framework, we created an initial Spring context called an infrastructure context. So we create that. We make it available in the Spring context, and I'll get into that in a minute. So we interleave, then we start the framework, then we create the main Spring context, then we register the context, and then we do the startup. But what was the point of doing that? The point of doing that is going back to the initial idea I mentioned at the beginning, which was identifying where in your application you may already have services, the idea of services available to you, so that you can begin to map the concept of services first migration into OSGi. And the main idea here is that you can literally consider all of your Spring beans to be services. So here is just a little bit of code that shows iterating over the Spring context, finding all the root beans because those are the only ones you want to make available. Iterates over the root beans and literally publishes them into the OSGi framework as services. Boom. So we haven't even built any OSGi bundles yet, but we already have all of our services available to us inside the OSGi runtime. Beautiful. But that's not enough, because the only bit of information, the important concept in an OSGi service is not only that you have an ability to fetch it from the service registry. The really crucial and important part are the properties associated with the services, which allow you to do filtering and being able to select very specific subsets of those services. And so we needed this ability when we wanted to migrate the Spring beans into OSGi, but they're not OSGi services. So how do we do this? And it was easily achievable with a simple annotation class, which allowed us, which was not an OSGi, it's not using an OSGi specification, but it's basically implemented here. Some of the methods are hidden, but it's just a very basic runtime annotation, which allowed us to annotate the beans in our Spring context with extra metadata that we could use inside of OSGi. It looks very much like the component annotation and behaves very much like it, but what it also allowed us to do was to map the legacy configuration that we had in our gigantic configuration files as subsets of properties that would be automatically pulled and merged into the service properties when it was pushed into the service, into the service registry. All right. So you have a framework now embedded. You have all your beans inside of the framework available as services. You have service properties on those beans that you created where you needed them. But the next part of the world is getting your application to consume services when those beans are outside of the OSGi registry. because you want to begin to, you're migrating and it's going to take time, so you still need to consume the functionality that's going to go into the OSGi framework from your main application. This will allow you to gradually migrate subsets of those beans directly into the OSGi runtime, create services, and reconsume those services from your outer application. And this was achievable with a fairly easy implementation of a registry bridge. So if you remember the jar files that were in the core class loader when we create the OSGi runtime, we created another API called just the registry API. And this registry API is available in the shared class loader of your application, but it's injected with an implementation that has a hold of the framework API, which allows you to track and register services. So here you can see an invocation of that, and what it allows you to do is from your regular Java, plain old Java code, create a service tracker, which is going to bring the dynamicity of the OSGi framework into your static Java application. So now you can move your implementation beans inside of the framework and consume them from the outer application. And this is literally backed by the real framework, so you can use all the power of service filtering. We added a small wrapper to be able to create service tracker customizers, so you can customize the behavior of how the tracking happens. And so the first one is using a service or creating a service tracker, and you can see here that I'm looking for all the services of type polar processor with the property JavaX portlet name / whatever, has to have that property. And not only that, but as you're migrating the legacy software, you may want to take certain implementations and be able to publish into the registry as well, programmatically, because you may not only have Spring Beans, you may have some other frameworks where you are creating service-like objects, but you need to make them available to the service registry. So you can do that also through this API by having the opportunity to register your services and being able to manage the service registrations for those so that you can control the life cycle. You can publish and then you can register into the service registry and then unregister. So now we have integration with the Spring framework. We have this framework running embedded. We have registered services into it. We can programmatically register services into it. We can track services from it. So now we can literally take chunks of code from our main application, push them into the framework, and we're ready to go. So here's legacy code invoking the service registry to re-implement some managed collection of objects that we had. So somewhere in your Spring code, you have a collection of some type that you're using, event listeners or whatnot, that you would traditionally have registered through your Spring Beans. Here we just flipped it around. That collection is actually being managed by a service tracker, which is dynamically updating a concurrent collection. So as the system evolves, we're literally updating the static part of the application. So the dynamics are working just as well inside of our outer static application as they are inside the OSGi framework. This is already a really huge start, because not only do we have a OSGi, can we write OSGi bundles, but we can pump OSGi services into our legacy application with almost rewriting no code, just those registration and integration points. So that's the main crux. There are many more things to consider. For instance, you may need to support legacy packaged applications. So for us, The traditional way that we had implemented pluggability in our application was to have a bridge in the app server that would allow us to see other web applications. And so third-party developers would create wars, literally wars, that map to our shared APIs in order to pull the functionality into our web application. And this was not working well for us, I would say. However, we already had an entire ecosystem of third-party developers, customers who had built customizations on our application that we didn't want to force them to completely rewrite their applications when they were moved to a new version of our product. So we had to deal with that packaging. And so we implemented a WAB specification, which meant that we could take those legacy wars, and when they deploy them, we would dynamically convert them into OSGi bundles. And so they would run inside the OSGi framework. And on top of that, because they're using our frameworks, we could identify the things that they intended to be services in the traditional model and convert them into OSGi services for free. So they'd take their legacy application, drop it into our new version of our application, and they magically get OSGi services alongside their running implementation of their legacy code. It's beautiful. Now, another thing that's complicated is dealing with legacy UI. Our entire application was built using JSPs. Hundreds of JSPs, probably thousands of JSPs actually. And as we all know, the JSP support in OSGi is I would call it half-baked at best. The implementations that exist try to take the easiest approach to implementing that, which is literally taking the Java EE implementations, wrapping them in super bundles, and then trying to make them work in OSGi. And that's really, really heavy. It meant a huge dependency tree, and we're trying to minimize that. Not only that, but it has no knowledge of OSGi at all, which meant that when the runtime compiler of the JSPs runs, you need to give those bundles a complete view of the world. Otherwise, they will miss all kinds of dependencies at runtime, and that could potentially blow up in your face to a very large degree. So we needed to have a JSP compiler that was OSGi aware. So that involved implementing or taking Jasper, having some changes made by Oracle and the Glassfish implementation, which they happily took, which allowed us to create a new JSP servlet with a JSP compiler that was OSGi aware. So now people could use their JSPs, or we could even recreate our JSPs and use it in OSGi. And then not only that, we were able to add modularity onto tag libs and so forth through this new JSP compiler. So you could build modular web applications using JSPs. It's not the most beautiful technology, but JSP is definitely entrenched in enterprise, particularly ours. So there was no way that we could move forward without having some form of support for this. And another concern, I spoke to a gentleman yesterday who had the same issue when going into modularity, and that is web application resources, or web resources, CSS, JavaScript, HTML. How do you deal with these resources, particularly when you're creating a composable user interface? In other words, by composable, I mean multiple disparate vendors' applications being inside the same UI at the same time and avoiding conflicts. And then also not duplicating the resources and collisions between different versions of resources and whatnot. So we built a framework on top of that, and that's something you may have to consider because there's no standard way of doing this now, but it's something we're discussing in the Alliance to try and figure out and even work with other language groups and packaging groups like the Bower community and the NPM to be able to automatically convert web resource metadata into OSGi so that we can use the power of the OSGi resolver to analyze the dependencies and pull those automatically. But it's a complex problem, so it's one of the very important things you need to consider. And I'd just like to give you some time to ask questions because
we have a few moments for questions. Are there any questions for Ray?
With that technology, how is it when you have such a big application? You probably have, let's say, 50 developers.
Yeah.
And they're basically probably JE developers. How did it go then to, let's say, learn the OSGi way?
So
Are they happy with it?
that's a very good point. We very carefully selected a minute subset of OSGi technologies to work with, specifically to avoid the need for developers to have to wrap their entire minds around the new technology. So because most developers are at least partially familiar with how annotations are used for component frameworks such as CDI and Spring, we leverage the power of declarative services to kind of ease their minds to not be too far away from something that they already understood. Because declarative services is a relatively simple model to understand. We also use B&D to its fullest capabilities, which is the metadata generator, the tool that creates OSGi bundles. If you use it properly, the developer practically has to do nothing in the configuration of their bundles. Because B&D is very, 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 very powerful and can do, with the right plugins in place, it can literally take all of the need for the developer to have to deal with any of the bundle configuration. And I'm not going to say that there's no ramp-up time. There is ramp-up time. You will lose productivity for a while. But in the last 6 months, our team of 60 developers created over 300 bundles. That's extracting legacy parts of our application and building well-formed 300 service-oriented bundles. We are well over 500 bundles already in the last 2 years. So the on-ramp time was not insignificant. And this is something you really have to consider. However, the trajectory changes fairly quickly once developers wrap their minds around just two things: declarative services and metatype. Metatype being the ability to configure your individual services and bundles. So learning one set of annotations for your components and another set of annotations for defining your configurations, as long as you know that, you almost have 90% of OSGi's power right there. You don't even have to worry about the rest of it. The beautiful part is to really drive home the idea of services and inform people that they've been using services for a long time, because they have. Because a Spring dependency is a service. A struts configuration action declared in an XML file is a service because some entity is expecting to track those types. So anywhere you have in your code some controller who is tracking some types and then operating on those types, those instances, that's a registry. And you can literally replace that with a service registry. So we took around 100 extension points in our legacy application and converted them all to dynamic. Every integration point in our static application has dynamic integration points. And not only that, once developers found out they could do that, we created 100 more integration points overnight because they realized how much more powerful it was. Not only that, we realized there was 25 different ways of implementing integration points in our application. We were doing it differently everywhere. And that's just the nature of developing things from scratch, right? When we moved to OSGi, we realized 100,000 lines of code could be unified into an abstract implementation. So that was really hard to realize when people are working on different parts of the project. They're not looking at everybody's code. So it's really important to find those places in your application where the mapping is trivial and then driving that idea home. We also did, we converted from less OSGi friendly frameworks to frameworks which were more friendly to OSGi. For instance, luckily we had no JSF UI in our web application. And the little tiny bits that we had, we simply migrated away from it because the benefits just outweighed the cost of trying to re-implement that. It was much easier to re-implement JSP than to do the whole JSF stack, right? We didn't have any Spring MVC UI, Spring MVC for our UIs. We had our own MVC framework plus struts. Struts for legacy because our portal was built 15 years ago, and so we still had a struts core. So we just migrated everything from struts because struts was literally just a service model. You just have a whole bunch of controllers defined with some metadata and a central registry handling all of those. It was a very easy mapping. So almost none of the UI had to be re-implemented. We literally mapped the UI so that it was exactly the same code inside of OSGi. Done. Any other questions?
So a couple more minutes. Any more questions for Ray?
Yeah, there's one at the...
So what happens when a service, an OSGi service that's already published to the Spring application context goes away?
It's impossible. How would that happen?
Well, you restart the bundle, dependency becomes unsatisfied.
Okay, so you're talking about when one of these legacy integration points.
Yeah.
So this managed collection, so there is a place where you have to consider the fact that some previously static behavior could suddenly go away. And you have to deal with that gracefully. So we would literally just put contingent code around that to make it a little bit more intelligent. Or we had the more frequent case in our scenario, and that was lucky for us, is that we had kind of like the event processing model far more often than we had a static relationship. So we had some form of managed collection. We have 4 implementations of POP3 integration or whatever, email integration. So, there's a map and you're checking for a particular one. Well, now the collection is just simply managed and you must always treat that collection as dynamic, right? So you take into account that what you're looking for might not be there. So that is definitely something you have to do some refactoring around. It's not going to always be a literal one-to-one mapping like this actually was a literally one-to-one mapping. But in many cases, you may not be able to do that. You'll just have to add a little bit more logic. But in some cases, it's trivial. In others, it's a little more complicated, but it's a trade-off. This allowed us to actually do our migration over the last 3 releases of our product. And our customers never even realized that we had hidden OSGi framework running inside. And it wasn't until, it's not until our new release where developers will actually have access to build their applications using OSGi. But we're promoting a very, again, limited set of functionality to people who are just starting out. And we're trying to promote the best practices that we've come to, which is declarative services and meta type. And then just using good build tools to minimize the amount of effort that developers have to put into creating their OSGi bundles. And it's from all of our early interaction, we've had already probably 7 or 8 different conferences this year with our community, and the it seems very encouraging. Our community is very encouraged and excited about it because it's given us much more power in our product.
Well, clearly, Ray, you've got a lot of experience at doing this and very passionate about it. So thank you very much. And if you want to ask more questions of Ray after the session, please come on up. But thank you very much, and thank you, Ray.
Thank you.